Hello and welcome back to another video. In this video we are going to solve the May-June 2019 970961, that is probability on statistics 1. So in this video we are going to solve only the questions from 1 to 5 and the rest 6th, 7th and 8th question in the next video. So without delay, let's start with the first question. Here's the question number 1. The times t seconds taken to swim 100 meter were recorded for a group of 9 swimmers and were found to be as follows: 95 seconds, 126 seconds and so on. And we need to find the values of sigma, that is summation t minus 120, and square of sigma of square t minus 120. So we can find it in two ways. One is, like we know, sigma of t minus 120 is going to be, it's like a summing them all these 9 times, so it can be written as sigma of t minus 120 into 9, or we can simply subtract 120 from all and then we can add them all. So I'm going to do in that way because we require the square of it also. So sigma of t minus 120 is going to be 95 minus 120 plus 126 minus 120 plus 117 minus 120 plus 135 minus 120. Similarly for others. So now we'll solve these values and we will get from here, it is going to be minus 25, and from here it is plus 6 from this. So if we'll add them all, we will get the answer, and that is going to be 15, it is going to be 3, 15, 5 is 20, 23. So minus 2 minus 2 minus 6 is minus 8, minus 9 plus 16 is going to be 7. So the answer for sigma of t minus 120 is going to be 7 only. And now from here it is easier to calculate the t minus 120 square. That is going to be square of first term, that is minus 25, then 6, then minus 3 square, then 15 square, then 5 square, then minus 6 square, then minus 1 square, and then 16 square. We could have done it directly because it is of 2 marks, so 1 mark for this, 1 mark for this, and this value we'll calculate from calculator and write the answer directly, and it is 1213. This is the value of sigma of t minus 120 whole square. So now we have both. Let's solve the second part of this question. So in the second part, using your values found in part 1, calculate the variance of t. So first thing, we know that variance of t or variance of, let's say, t minus 120, both are going to be same because this adding or subtracting any extra constant does not change the variance. So in order to find the variance of t, we'll find the variance of t square, variance of this, and this is going to be summation of t minus 120 whole square divided by n, that is 9 here, minus square of summation of t minus 120 over 9, that is n whole square, and this is going to be 1213 divided by 9 minus this value is 7, so 7 square divided by 9 square, and now this value is going to be 1213 divided by 9 is in the decimal, so I'm going to calculate it directly. It is going to be 49 divided by 81. So the answer is 134.172. So it is 17, or till 3 significant figure we'll write the answer. It is going to be 134 only. So that is the answer. I hope it is clear. Let's do the second question. Here's the question number 2. Jamil has 5 plums, so for Jamil 5 plums and 3 apricots, and Rosa R has X plums and 6 apricots. In a box, one fruit is chosen at random from Jamil's box and one fruit is chosen at random from Rosa's box. The probability that both fruits chosen are plums is 1/4. Write down an equation in x and hence find the probability, hence find the value of x. Now, so since it is both fruits chosen are plums, so first of all we need to find the probability that we got plums from Jamil, and that is going to be 5 over total, that is 8, and probability of plums from Rosa's box, that is going to be P of R, and it is x over total number of fruits, that is x plus 6. Now if it is both, it means first also it is going to be plums and second also it is going to be plums, and this value is given as 1/4. So if we replace this value, we are going to get 5 over 8 into x over x plus 6 as 1/4. So this is the equation in x. Now we'll solve for x. So it is going to be 5x into 4 is equal to, cross multiplying I'm doing, and 8 into x plus 6. So 4 2s are 8, we can cancel here. It is 5x is equal to 2x plus 6 2s are 12, or 3x is equal to 12, and hence x value is going to be 12/3, that is 4. So the value of x is equal to 4, and equation is this one. I hope it is clear. Let's do the third question. The question number 3, a fair 6-sided die is thrown twice. So thrown twice means total number of outcomes we can notice from here, that is going to be 36, 6 into 6. Event x is defined as the total of 2 scores is 4. So it is going to be 1 3, first one, and second 3, or 3 and 1, or 2 and 2. There is no any other possibility for this when we will get the score as 4. Event y is given as the first score is 2 or 5. So first score is 2, so second score can be 1, 2, and then second square can be 2. Similarly till first square 2 and the last is 6. Similarly for the 5, it is 5 1, 5 2, and so on till 5 6. So these are the possibilities. Now we need to find our events x and y independent. So we know that if x and y we need to find independent, means like if you're finding x given y, it is probability of x, then it is going to be independent. Or we can say x and y are independent if probability of x intersection y is same as probability of x into probability of y. So we are going to find the probability both the sides, and then we will calculate the probability, and if they are equal, then they are going to be independent. So one more step, I will calculate x intersection y as well. So x intersection y is going to be collection of those outcome where the first score is 2 or 5, and the sum of the score, total of the score is 4. So only possibility is 2 2. So this is going to be singleton set 2 2. It means probability of x intersection y is 1 over 36. 1 out of total, that is 36. Now the probability of x is, there is going to be 3, so 3 over 36, that is 1 over 12, and probability of y is 6 6 12, 12 over 36, that is 1 over 3. And since we can check now from here that probability of x into probability of y is 1 over 12 into 1 over 3, that is 1 over 36. So this implies probability of x intersection y is same as probability of x into probability of y. That's why we can directly write x and y are independent. So I hope it is clear. So we could have done like what is the probability of x given y, and then we can show that this is exactly same as probability of x. In that case also we can say that x and y are independent. Otherwise we can always calculate intersections probability and the separate probability, and we can see if their products if they are equal, then it is going to be they are going to be independent events. Let's do the fourth question. Here is the question number 4. The mathematics and English A level marks of 1400 pupils are taking the same examinations are shown in the cumulative frequency graphs below. Both examinations are marked out of 100. So this is cumulative frequency graph given. I'll zoom out to see the full graph. Now see, this is the cumulative frequency graph for maths and this is for English. So the question comes in the next line, that is, use suitable data for these graphs to compare the central tendency. So we know that central tendency we measure it from median, and spread of the marks. So spread of the marks we can measure it from either interquartile range or the ranges. In mathematics and English we need to compare them. So for that purpose we require the median, that is 50%. So I'll draw the diagram here and the corresponding values for median, interquartile ranges. So here it is. Now we can draw for median. It is, since there are 1400, so for median it is going to be 50% of them from the quartile from the cumulative frequency graph. For median it is going to be 50% of 1400, that is 700, and 700 for mathematics we can see. I'll write median for maths, it is going to be for 700 this curve, and it is coming down to at 40, so it is going to be 40 marks. And median for English it is going to be the same line at 700, goes here, come down at between 50, 52, 54, 56. So between 54 and 56, let's take it as 55. So these are the median. So we can say directly that median of English is more than median of mathematics. I can write maths. So median gives a central tendency, so it's like on average the median marks of English is more than the median marks of mathematics. Now let's calculate for the central spread of the marks. So for that we'll calculate Q1 and Q3 for maths. Let's say first of all maths, Q1 is going to be 25% of the total, that is 1400. So 25% of total is going to be 350, which is going to be here, and for 350 and maths it crosses here, so will come down and it is going to be 10 and 2 again, so it is 12. And Q3 is 75%. 75% of 1400 is 1050, which is here, and for that mathematics you reach here, and when you'll come down you'll get it as at 80, so it is going to be 80. So interquartile range for mathematics for M, let's say mathematics, it is going to be 80 minus 12, which is 68. And for English we can calculate, for English it is going to be Q1 from here. Again there are fixed number of students, so we'll only need to see where it cuts here, and it is coming at 42. And for Q3 this line touches here and come down at 62. So from here interquartile range for English is 62 minus 42, that is 20. So we can see from here that mathematics marks are more spread than the marks than this spread of English. So we can write the last line as mathematics are more spread than English. So I hope it is clear. Let's do the next question. Here's the question number 5. In a certain country, the probability that a child owns a bicycle is 0.65. A random sample of 15 children from this country is chosen. So this is fixed 15, and find the probability that more than 12 own a bicycle. So they are focusing on the owning of bicycle, and it can be taken as a binary, because it is like going to own, a child is going to own it or not. And for every each child the probability is same throughout, and it is random, so it is going to be binomial with n as going to be n is 15, and we can take x as the number of child who owns a bicycle. So that's why the success probability corresponding to owns a bicycle, it is going to be p, it is 0.65, and hence the failure probability q, that is 1 minus p, it is 0.35. So it is binomial with n as 15 and success probability as 0.65. and now we need to find the probability of x more than that is greater than 12. So it is, we know that for more than 12 it is 13, 14, 15. So we should find it as probability of x is equal to 13, or probability of x is equal to 14, or probability of x is equal to 15. Now we have the formula for this. It is NCR, so n is 15, CR, R is 13 in this case, and 0.65 to the power 13, and the failure probability is 2 times 0.35 to the power 2 plus 15C14, 0.65 to the power 14, and 0.35 power 1, that is as it is now. And the last one 15C15, 0.65 to the power 15 and 0.35 to the power 0, so no need to write it. Now we will calculate this from the calculator, and we will get the answer as 0.06173, so 617. So this is the answer till 3 significant figure. That probability, this is the probability that more than 12 out of 15 owns a bicycle. So I hope it is clear. Let's do the second part of this question. Here's the second part. A random sample of 250 children from this country is chosen. Now see, this number of students are large, 250. Use a suitable approximation to find the probability that fewer than 179 own a bicycle. So we know that if the number n is large, and this probability of success is approximately like close to 0.5, which is 0.65, it is closer to 5, now 0.5, then this distribution is approximately normal. So we can say this binomial distribution will become can be approximated with the normal distribution with the new mean and variance. And you know from the from here we know that if it is binomial, then mean is going to be n into p, that is 250 into 0.65, and variance is n into p into q, that is 250 into 0.65 into 0.35, and these values we'll calculate from calculator, and this is 162.5. and this variance is going to be 56.875. so once we have these two values, we can calculate the probability, and the probability we need to find is x fewer than, so less than 179. Now we are approximating the discrete random variable to continuous random variable, so we will use the continuity correction, and for continuity correction we will again see the same thing. It is 179, so the previously it is 178, the next value is 180. so if we are going to this direction, because x is less than, so we are going in this direction, and we are not including 179, so we will not include this whole bar, and that's why this will start from 178.5. so this is same as probability of x is less than 178.5. this is the continuity correction, and hence we'll standardized it, and it is going to be z is less than 178.5 minus mean is 162.5 over standard deviation, that is square root of this value 56.875, and we will calculate this value, and this is going to be z is less than 2.122 nearest to 3 decimal places, and this value we will get from the calculator, from the distribution table, and this value is going to be 0.9830 plus for 2 it is 1, so it is going to be 0.9831, or till 3 significant figure it is 0.983. so that's the answer. I hope it is clear, and we will discuss the next 3 questions in the next video. Till then, thank you so much.